Recording has started. Hi everyone. Welcome to the uh, PyTorch which we are promoting to make sure that that is the common what you call the most common framework which we'll use for the development of all the RISC-V based implementation, especially any models that are required. So I'm putting it on slideshow and you can tell me if you are able to see everything properly. Mayank, can you see?
No, sir, no screen visible.
No screen is visible?
No,
Oh,
sir.
okay. So maybe I have to reshare it again. Let me share again and then share, share screen and PyTorch screen. Uh,
Yes, sir, now it is visible.
now you are able to see?
Yes, sir.
Okay. Hi everyone. Welcome to PyTorch to RAGathon. Now why RAGathon? I'll tell you. We want to have a hackathon sometimes in the March 25-27 time frame, which is going to be our TechFest 2025, and that will be done on the Geo Meet, Geo event, for which we are already planning. This is February 15. So this PyTorch to RAGathon will continue every uh, Saturday, same time for next 18 to 20 weeks. But initially, I'm going to focus on people who are at least 18 plus. Anyway, we are not allowed less than 18 to be brought in as a children's are not allowed. And this is for intermediate curriculum. It means that we assume that you know Python to a certain extent, and you can pick up while you are doing it. And this is for college undergraduates as well as those who are 12th pass and all that. So college people and undergraduate students. It doesn't mean graduate cannot, but minimum you must have some background on Python with some college or some mathematics background. That's all we care. And even mathematics may not be so strongly required, but anyway, because we are focusing on the RISC-V vector processing units, so for acceleration, we may need that. So first, what is the objective here? To learn, understand PyTorch and its use in RAG. RAG is a term, it's also a framework. PyTorch itself is a framework, RAG is also a framework, but RAG is for retrievable augmented um, generate generation. That means what? You have, let's say, a function fx, y equal to f of x, let's say, where x is the input, y is the output, right? So if you do input as x and you get some function and you get some output, let's say vector function, right? So if you have a vector function which is like vector add, then you have two vectors as input, v1 and v2, or your output are your output will be y, which will be f of x1 plus f of x2, right? Or f of x1 plus x2. That is a addition, right? So basically what it means is you are doing some function and that function has some output. But if I say that I want to have whatever is output so that I know I can add one more vector to it, then you will get those and then put it as an input and add one more. So it means you will say f of x1 plus x2 plus f of x3 equal to y. So basically, whatever is your output, if you are going to feedback part of it or full of it, then that is a retrieved answer you got already and then you are feeding it back. So that means that is the retrievable augmented generation. That means you use RAG as it's a term used. So just clarifying what it means. It means your output, you're feedbacking as an input for part of it and then let the um, model calculate it. Now, what is model, what is framework, all that we'll see. But the objective here is to use PyTorch. PyTorch is a library and it's a framework with libraries which can be used for modeling. And that model we want to use by taking the output and feeding it as input, and then we want to go to RAG model. And RAG, why RAG? Because if you have a local machine, you don't have a GPU, you don't have anything, you just have a CPU, you don't want to share what you want to do with the world unless you know that it is working inside before you host it. So basically, if you want to do something at your own laptop level, not worry about this cloud and keep paying them, then you do it with a Olama, they call it. I'll come to that, but at this time, the idea is we don't want to depend on all this host and keep paying money to all these cloud providers unless it is a deployment. If it is a deployment, then you need to scale. You don't have the scale or you don't have the enough compute power to manage it, then you give it to the. So example, Sujay here is a collabcloud.com provider. What Sujay can do is he can build models, or we can build models and give it to him. He can throw it on the, once it is production ready, then he can throw it on his Collab cloud and people can use it. Where if we need GPU, we can get it, and it may not be, it could be in the private space so that we are protected. We don't want everybody to know what we are doing. Okay. Now, what are the materials we are going to cover? What is the use case of AI? There are many use cases, but we'll talk about only few. What is PyTorch and its role in AI landscape? Then the role of big data and need for XPU in DNN. DNN stands, every terminology I'll explain. XPU is so accelerated processing unit. Normally what happens? You use GPU, correct? And GPU is very power hungry, so it consumes a lot of power. So we don't want to use GPU at the edge. We want to use at the edge a accelerated processing unit. And usually XPUs they are called, and especially EOTF, we are focused on AXPU, which is accelerated application accelerated processing unit. RA stands for, so that we can brand it. We don't call it as XPU, we call it AXPU. That is to brand it, because you cannot brand a number, you have to have a specific. We cannot take XPU and brand it, but we can do a AXPU as branding. Now A stands for what? A can be a vector processing, A can be a matrix processing, A can be a crypto processing, A can be a floating, what is that, tensor flow processing. It can be any scientific or business. So you can term it as application, you can call it arithmetic, you can call whatever. A is our term, AXPU. So if I say AXPU, you assume it is XPU, it is not GPU. GPU is too powerful, requires, if you put on a one machine, a GPU, and if you have a rack of full of, with rack is around 12 to 15 servers. If you have 12 to 15 servers and each one of them consumes 2000 kilowatt, then you are running a, what you call a powerhouse you need at the house. Whereas entire server generally take 250 watts, and if you have a 48U, 1U stands for 1.75 inch, which is around 4 centimeter or something of that kind. So usually you say that 250 into 12, that means whatever that comes out to 250 into 4 is around 1K, and that is 250 watts I am talking. So 1 kilowatt for 4, if you have 12 means 3 kilowatt. So you don't need more than 3 kilowatt if you don't have any GPU or XPU. If you have XPU, maybe you have around 30 to 40 kilowatt maximum. Whereas if you put a GPU on every server, then you may need something like 40 kilowatt or 50 kilowatt for per 40 into whatever that is 12 means 5 that is you will require 500 kilowatt, right, which is 5 megawatt. So it's just weird that if you do too much acceleration and you use high performance computing, then you need the whole hyper converged data centers, and that means you waste your for a small things you waste unnecessary power. So the idea is to reduce the power. Then LLM stands for large language model. Sorry. So when we say use case of AI, we are considering two use cases. I'll say what are they. One is the computer vision, and other is the language transformation or use of LLM. Diffusion models are generally ones like if you say, hey, give me a picture and then give an input. No, just write in text. I want to see Delhi, beautiful Delhi with the India Gate. So it will draw some image of that. So that means you are giving an input to the model and the model is generating the picture for you. So that is a diffusion model. And what we want to use is we want to use PyTorch as our deployment model. Now, frameworks are frameworks. We'll come to that. Frameworks can be used for training. Frameworks can be used for deployment. It can be either or both. Okay. So framework is one thing which in itself doesn't do anything except putting the place what to put where, and you use that to build the model, to test the model, to deploy the model, to execute the model, etc. Right? So we are going to talk about these 5-6 things. So the objective, what we have set here for learning in this specific session is what are the typical use cases of AI? I don't have to explain AI. AI is artificial intelligence across industries and their market potential. There is a lot of potential for AI. That is why everybody is jumping after AI. Then the role played by PyTorch in current AI landscape. So what is the current AI landscape? Why PyTorch is important? Then you know about big data, means you can get lot of data, big and bigger and bigger and bigger, but humongous data don't mean anything until you are able to filter it. And not only that, after filtering, you are able to use it in a way so that it can be simplified, accelerated, etc. And this acceleration happens through XPUs or GPUs. I am putting GPU because most of the people understand GPU. If I say XPU, they say what? But graphic processing units are one of the earliest ones to be used for big data processing. So there is a streams of data and you want to recognize a dog or a cat, then what happens? You collect all the features of the dog and say, oh, the skin is different, the eyes are different, and so on and so forth. So those are called features. So you feed the features of the image by scanning the image picture by pixel by pixel and stream it as a serial data into the function and the model, that is, and the model is algorithm will say, hey, this looks like more to me a dog or a cat, or it is in between dog and cat, I don't know, types. So whatever the inferencing is done, that is based on previously you have to train it, and once it is trained, then you can throw some random dog or cat at it and it will say, yes, this picture looks like a dog. No, this is cat. I don't know what this is confusing picture you have given. It's a dog cat, looks like to me. So depends on how the big data, now this need not be all the object or images, it could be text. That is where the difference between the use cases come. One is text-based use case, LLMs, large language models. Diffusion model is generation of image, whereas the image which you input and you get some inference from that, that is that could be training or inferencing. So there are always two parts, training part, inferencing part, training part. So XPUs are more useful on the inferencing side. GPUs are more useful on the training side. So if somebody gives you a ready-made model, why do you have to worry about training it? It is there already. Only thing you need to do is you have to set the context for your own. So that is what we'll look at. Now, also finally, the objective is to understand PyTorch ecosystem and what are the deployment options. So let's start with it. Now that we have already spent around 20 minutes, I am just going to merge a lot of things here. But first, we'll look at all use cases. Computer vision and LLM are the two use cases we are going to look at. Then we are going to look at PyTorch, that the AI development and deployment, both development and deployment. It's a framework we are going to talk about. Then we are going to third, we are looking big data and need for XPUs for distributed neural networks, DNN. There are many terms, CNN, DNN, ANN, so many, but we'll explain what is distributed and what is neural network. We'll get into details of large language model and diffusion model. Diffusion model may not be very key for us, but definitely we want to get a little bit more about what are the large language models. And finally, we'll look at PyTorch ecosystem and deployment models. So even though I am repeating this, but this is to give you the context how we are going, and we start with this. So first, use cases. Two types of use cases we are addressing. Industry has got many, but we are scientific oriented, and what can we do in R&D and what can we do in mission business critical deployment. So there is a toy which you can play with, or you want something, a toy which is actually usable. Okay, a robot can be a toy on your desktop or walking in your room, and you can control it, but you can also use it in industry to move the goods around, right? So without really stumbling across somebody else or banging with the machine, and also safeguarding and all that. So that is business critical or mission critical. So when we say PyTorch, first thing is PyTorch is an open source neural network framework. Okay, open source means what? It's available, anybody can use it. It doesn't have to be licensed. Okay, it is available under Apache license or some license which is reasonably good, like MIT, or it could be BSD. If you do any other license, maybe you have to pay the license fee, but we can do without that by just using PyTorch framework, which is free for all. Now, PyTorch is a Python based open source. First thing you remember. So if you know Python, you already know that it is some bunch of libraries put together and models put together. But it is not the models, it is the framework. Framework is not model. Model is framework is used to develop models. And models are nothing but algorithms where you have, like f of x I explained, to fx1 plus fx2 equal to y equal to f of x1 plus fx2 plus retrieved f of x3, and that is like y equal to mx plus c. If you do the linear algebra coordinate geometry, m is the slope. And so in the neural network framework, you do a lot of derivatives, or you try to get, if you have a convex or a concave, let's say convex. So if I have a u on a coordinate xy system, and if I point at the top of the u on the left side, then if I tell that I want to reach the minimum of this figure, then it will keep on doing from top to the bottom in steps. And when it reaches the bottom, it will not go any further. Or when it is somewhere in between bottom on the left or the right, it is just flipping between the two. That means there is some error. So that is nothing but you are trying to take the slope of slope of slope of slope until you hit the optimum point which you want to reach. In this case, it is minimum. All right. So now how do you do that? That is using neural network. Now, what is a neural network? Then the question comes, okay, so what we do normally is you give weightage, like y equal to mx plus c. When we say y, then if you change the y equal to mx is single word, single line, right? But you may have many data inputs. So when you do parallelly process so many data, then the question comes down to what will be the weights, right? So the weights may differ, and so by changing the weights, you are trying to. So this is like an okay. First thing is, what is neuron? If you look at your brain, or if you imagine your brain, it has got several neurons. And neurons is nothing but it is a node. And that node, when it receives some trigger, it will go and tell somebody else, the next neighbor, that, hey, this happened. So when your hand is shivering, that is impacting your brain will listen from the backside, oh, this guy's hand is shivering. So then it will pass on that trigger to another, to another, to another. So there is a network of neurons. And those neurons are represented by activation functions. Now, activation function, one of the, so it's like a example, if you have a trigger, what do you say? Oh, in electronic, you say, oh, this is a step function. That means what? Suddenly it will go 0 to 5 volt and then it will remain there. Or if you have a XY coordinate and we have got a line which is going, it is 0 for all negative voltage, then it will be 0, it will be along the minus y axis. And suddenly it will go 45 degree. That is when it is said to be linearly going up. And then after some, let's say it starts some point and then it then becomes flat, something like that. So basically what it means is ReLU is a activation function which is 0 less than 0, that is x equal to 0, y equal to 0, less than x, that is x is negative or y is negative, it will be 0. When x becomes positive, the y becomes a little bit 45 degrees, right? Now why that is important is you must have some non-linearity. If everything is, if you take two linear functions and you put a weight on it, like example, one is at 45 degree, first x1, okay? And therefore I have got a y1 equal to something greater than 0, it has some value. Let's say 1, 1. And I multiply that by 0.2. So what it means is it becomes 0.2, 0.2. I take another one, I multiply that by 0.3. So it is 0.3, 0.3 because we know 1, 1, it is going through 1, 1. So one has a 0.3, 0.2 into x1 plus 0.3 into x2. And then that is what is the addition, right? So now if you draw, normally what we do is everything we describe in terms of a graph, some kind of a graph. That means what? If a trigger comes, we say this is some graph, approximation, right? Okay, this looks like this is this graph. Now I am approximating that by some combination, linear combination. We call it as some polynomial. So a x1 plus b x2 plus c equal to f of x. So what we have done is x1, x2, and then there is a constant bias. So we have added, we have actually created a linear equation, but a and b are weights. And those weights can be, one can be 0.2, one can be 0.3. So if you are multiplying by a ReLU activation function, the combination of that becomes nonlinear. Two linear functions, even though ReLU is a constant, it's a linear function, by multiplying, giving a weight which is different, you are making it nonlinear. That means what? One is doing 0.2 up, one is going 0.3 up, and they are on different values. By weights, we can multiply and add, and we can create any nonlinear function we want. So it is important to know that neural network is bunch of nodes. Each node is a neuron, and in this case, we are doing artificial neural network. That means we are creating a node, neural node, which is an artificial node, and that we are adding weights and trying to get to a particular graph. So it is a fitting. Basically, all we say is, if there is a graph, I want to fit it. And not only that, if you say that we are fitting it, why do you want to fit? Because we want to optimize, let's say. So the basic issue of modeling is nothing but providing a pictorial representation like a graph and trying to reach the either the minimum or maximum or whatever we want to achieve. So that is the modeling in terms of algorithm or in terms of graph which we describe. So the neural network is nothing but bunch of frameworks. So just to give you idea, here it is. What is a neural network architecture? Here is the input layer and output layer. Input layer takes the input and decides to pass on the weights. Like you may find that I was talking about 0.2 weight, right? So whatever is that trigger, it has come, multiply by 0.2, activate and give it to this. Multiply by 0.3, give it to this. Multiply by 0.4, give here. 0.5 here. 0.6 here. And then this fellow, he gives 0.4, this fellow may give different. So all these calculations that are done, they are nothing but instead of ax plus ax1 plus bx2 plus cx3 plus dx4 plus ex5 plus whatever, right? So infinity, as much you want. Of course, that depends on how many you have input layer. So input layer is where you provide the input to the neuron. This is a neuron node, this is a neuron node, this is a neuron. All these are neuron nodes and all are giving input layer collects from the user and passes on to hidden layers. There are multiple hidden layers and connected through graphs. It's like a brain. This is representation of a neural network brain architecture. So it's a network. It's a network of layers, which each layer having multiple neurons on the input side as well as output side, and they are activated by ReLU, or they call it ReLU. It's nothing but a activation function. So these functions multiply, add, and this is one layer output. This is another layer. And so each layer feeds the other layer feeds the other layer, and this is feed forward. If it does back, then it is feedback. So normally feed forward and feed backward, you keep on doing, you doing approximation so that if you want to recognize a cat and you take all the bits and supply, then the output should look like a cat. So output should say, output is layer is what? That is the, what you call the classification layer. So in this case, we have got 4 results. So it could be cat, dog, or it could be a plane, or it could be what you call a vehicle, motor. So you can classify at the output whatever objects you want to recognize. Example, those objects can be recognized. And this need not be objects also. But for the sake of simplicity, so that you understand the brain's functioning as a neural network, we feed some inputs, we multiply add with weights, and there are as many hidden layers you want. You can have 10 layer, you can have 20 layer, you can have 100 layer, 1000 layer. And the parameters, in this case, we have 1, 2, 3, 4, 5 parameters. You can have 50 parameters, 500. They will talk about billion parameters. So all depends. But overall, the picture is like this. This can be dense, it can be shallow, it can be deep. Deep means more hidden layers. So 100 hidden layers is deep. 1000 is deeper. And so on and so forth. Or if it is only 2 or 3 layers, it is shallow. So depth is one. The other is the number of parameters that are input and number of outputs you are trying to classify. So this is your classification, this is your input, and these are the parameters, and you view them. That's what you do. So when we talk about this, you will say, why do I need to do all this? I can do in an Excel sheet, right? No, sorry. If you can Excel sheet, you can have 3 columns, 5 columns at the most. After that, you cannot even see where is it on the screen. So you really cannot have parameters more than 5 or 10. After that, you lose track. So it has to be done by somebody who is more automated, like PyTorch. Excel framework can do the job for simple things, but it can't do for complicated things. So you use PyTorch as an open source so that you are able to use this open source framework, whereby you are feeding to the neural net framework the input parameters, and try to classify or try to inference or try to train. This can be for training as well as for inferencing. Training means you feed, you know actually what it is. Your picture of dog, you are saying, hey, this is dog, take it, man, figure out what it is. Can you understand this? So it will store the value of it. And so what, how does it do? That is where the embedding comes. So that means when you provide the input to the model, what it does is it converts everything that you give, image or text or anything, it will be converted to something called as embedding vector. So that means what? If I know a Alsatian dog and a what do you call a Doberman dog, they will be dogs. So therefore their numbers will be closer to each other. Whereas if I talk about an airplane and a vehicle, they will be closer because they are vehicles, they are not this. But both of these will be distant. So it depends on how the encoding is done. So encoding means you convert everything that is given as input into some number, and that number is what matters for the indexing, so that when you, after training, when you give some input to it, it will go and look at the number. Oh, this is closer to dog, this must be dog. This is closer to car, so therefore, so that's the embedding. Embedding is used for for distancing between the closeness, similarity. It's a similarity matrix or similarity vector, you can call it, whatever. So the idea is to make sure that you train the model and you predict, and this is what the neural network do. So computer vision is for image recognition, object recognition and all that. It could be for a mission critical example, and all of these are based on gradient descent. Gradient descent is nothing but f of x, y equal to mx plus c, then df of differentiation when you do, it's nothing but slope, and slope of slope of slope of slope, you can keep on doing n number of time, infinity time, and that is the analytics. Excel sheet you can do analytics, but not do this big number of millions of data and millions of layers or billions of layers and all that. So gradient descent is formulated and PyTorch can execute that very well. So computer vision of identify IMG is one of the major use cases. I have just put cat and dog because it's easy to explain. But features like face, eye, ears, nose, legs, etc., you take as the features and encode them, and then you see that if the encodings are closer to each other, that is how you determine. And same way, if a vehicle is auto steering, means you have a car which is going and you want that car to be automatically steering, it will, on the top there will be a camera which is picturing, oh, road is there, car is there, this cow is coming here, train is coming here, oh, some cyclist has come, so it will adjust accordingly, right? So that is autonomous steering. So, or if you are going on the lane and you are saying you are touching the other lane and there is a gap between the two, you should not get into opposite side coming accident. So, or in the same side, two parallel lanes are there, you try to adjust. So that is autonomous steering and all. So these are all real life application. Just to give you an example, while cats and dogs are for the classes, for the research, but actual mission critical is like one plane flying over the another without accident. Is that, do you know whether it can go or not go? That those kinds of decision making. So those are inferencing. So other thing we have to talk about is large language model. The language, why we talk about language is because you feed some text. Now text can be in Hindi, English, Marathi, Gujarati, whatever, right? Tamil, whatever. So you can feed in any language, any question, it should be able to translate it. And then if you are in Maharashtra, then you will have a Marathi dictionary. Maybe you supply, hey, my context is I am only talking about Mumbai and not even Maharashtra's Marathi, but Mumbai Marathi or Mumbai Hindi. Then it can give you go to airport and then you feed to it, hey, मी कुठे आलो, you are, तुम्ही airport आलो, बरोबर? It is going to respond. So you are sending a query in some language, natural language we call it, that is why we call NLP, natural language processing. So it can be in English, it can be Hindi, it can be Marathi, it can be Tamil, whatever you give, it's able to process it, and it is going to use the local database, because it is in Maharashtra, it knows you are talking Marathi. If you are in Delhi, it will say, "Arey Delhi hai, Delhi wali bhai, hum jugaad karte hain yahan pe." So it will talk in terms of jugats. So how your RAG or the retrieval augmented generator works in the local is very important, because then RAG gives you the ability to put your own funda besides the command which you give or question you ask, it is able to answer you. So text, it can be text to speech, it can be speech to text, and all modes are possible. So there are different modes. So this gives you large language model concept. This gives you neural network architecture. Now let's look at PyTorch and AI development. Okay. So PyTorch makes it fairly trivial to use gradient descent algorithm at scale. So when we talk about scale means what? Not the foot ruler, but scale means it can scale. It means you can have millions and millions of input and yet it will solve. Of course, it will take time. The compute time is the premium. But nevertheless, you don't have to worry about what the algorithms, you don't even need to know what is gradient descent. All you are telling, hey, there is a library which says the torch.grade descent, okay, put it. Or this is called autograd. So there is a autograde. Okay. So allow developers to research and easily use the autograd. Autograd is one of the models. So let me see if I can show you this. Are you able to see now PyTorch?
Yes, sir.
So this is the fundamentals of autograde. PyTorch autograde feature is part of what makes PyTorch flexible, fast for building machine learning projects. It allows for rapid and easy computation and multiple partial derivatives referred to as gradients. Of course, we talked about the gradient descent. The operation is controlled to back propagation based on neural networking. So you can do a forward backward propagation, and so the whole detail is there. I just want you to go through this. I have the link. I'll send you the link. There are all mathematical partial derivatives, and when we talked about this is how the graph looks like, and then when you do something it creates all that embeddings, and this is how it is going to the minimum. So minimizing at 3 here in this case, right? So all this autograde is nothing but it's a training. So you do batches of and dimension, how many you want hidden layers, what are the output dimension and all that. You can figure out all those numbers and all, but it is automatically doing. It is not an Excel sheet where you have to worry about, oh, A, B, AC gaya, abhi to dikhta nahi. You don't have to worry about all that. It will do it on its own. It will draw the graph. You have got map plot and all that. So this is what we see as one of the uh, whatever the one sec, I'll go back to sharing. Okay, I have to stop sharing and reshare, it looks like. So Jamit, you are there. Good, thank you. I'll go share back, share screen. Okay, I come back here, I come back here. I hope I'm back to, that's why, are you back? Are you seeing?
Yes, sir.
Yeah, you are able to see now, right? So PyTorch makes fairly trivial means easy for calculating gradient descent at scale. At scale means it can be millions and billions of inputs and parameters and all that. No need to know what is the derivative. PyTorch does all that. Library has got autograd, and autograd will automatically do the partial gradients. Why partial? Because you have to do with respect to one variable at a time. When you do differentiation, you can do y with respect to x1, y with respect to x2, y with respect to x3. So you're doing partially and then doing some computation. So that is why. So it allows developer and researcher to easily try out different things without getting into complex models. So you can write one model today and destroy it tomorrow, retry with a different approach, so that it's easy to deploy to model and destroy and then remodel and destroy. You don't spend 6 months to build one and then afterwards, oh baap re, sab galat ho gaya, abhi wapas karna padega 6 mahina. No, not like that. So you can do daily model. People build daily models on this, so it's an easy one. So one of the models such as neural network, right? One model. There are many a model. One model we are talking is neural network. And details of these are available on the link. I'll leave it there. I anyway share slides with you. Now, when you use output of one neuron node to the next chain them in hidden layers, essentially we are creating nonlinear network. I already explained, right? We are creating nonlinear network by adjusting and revising multiple weights, making it nonlinear, trying to converge and reduce. That means we can do a faster convergence. Convergence, you understand, limit n tends to infinity. You want that it should do it faster. So your simplest of the regression model is you don't have any hidden layer. You have input layer, you have output layer. So example B plus Wx, right? Y equal to B plus Wx, where B is the bias and B is the weight and then X is the input. So you can do simplest one. Now, when did this start? This started with MNIST. NIST is National Institute of Standards in US. There is a MNIST database or dataset, which is SDNN means they have some spatial division 1, 2, 3, 4. It started with an, it means some 1819 now. Here you can see the sample images from MNIST test database. So what happens? This is a handwriting recognition for numbers. So how people write, everybody writes 0 differently, everybody writes 1 differently. So if my handwriting, I write, your handwriting, anybody said, so thousands of handwritings they collect, and this data set has got all the collection. So what you have to do is you have to compare, anybody gives anything, you compare that with this, and then 99% you will be able to detect it, or even higher than that. So, or it may be only be 60%, depending on what your computation capability is. So it can be 60. Initially, it used to be difficult. As acceleration became more and more popular, it became easier. So this is nothing but a set of signatures of different people, how they write. And if you give some input, like a doctor writing a prescription, yeah, you need to have 011515. Now you don't know whether the guy is writing 8 or 0 or 1 or 5. But if you scan, if you give this to this model will detect and give you correctly. Or number plate detection of a car. These are some applications. I'm just giving you, but provided they have hidden layers. If you don't have hidden layers, then you are just giving same input is equal to output with some modification without much change. It's just a scaling, simple scaling. So MNIST database is the one which is used. And sorry, now I'm coming to big data stuff. So we are moving to the next topic, which is why do you need XPU? Because of big data. Big data, what is big data? Big data is used, we talk about big data means lot of data, volumes of data. Now, this project started something called as AlexNet by the name of the person Alex who did this in 2012. Alex Krasensky, and he what he did was he said that I will create a lot of visuals of images, thousands of images, and they conducted a competition called Large Scale Visual Recognition Challenge, LSVRC. All details are there. And each year from 2010, I think it is 2010 to 2070, they kept on improving until they hit such a thing that they started using GPU, XPU and all that. They were able to process using deep neural network. Even though the MNIST database which I presented, that was started somewhere in 1990s, but actual real this processing started 2010-12. Those times up to 2000 it was all this MNIST and all handwriting recognition. After 2010 it changed into ImageNet, and ImageNet ran for up to 17, whereby so many improvements happened that by adding multiple hidden layers, 10 layers, 100 layers, 1000 layers, it became more and more complex and more compute intensive. So all this is showing that there are many models tried out, and all of this was happening in the ImageNet competition. That is ILSVRC competition. They had several of them, and initially it was never called as deep neural network. It was called neural network. Then somebody called it convolution neural network. And then they started with some multiple layers. So there are models galore you can see. They are CNN or DNN. Most of them initially CNNs, convolution neural networks, and they were like 16 layers, 19 layers. They are VGG, and then there was a RESTnet. So each one has a different philosophy, and we'll see the diagram next page. But all it means is residual net or RESTnet 50. So there were several companies, Microsoft on the RESTnet, Google was the most prominent one, which went into whatever Inception. Inception is nothing but a convolutional neural network model where it classifies images, and this was posted by Google in 2015 to classify, and they won the one of the uh, inception and then exception. Inception, exception are generally what you call a little bit different. The inception is more focused in using in such a way that they do sequence, where exception is doing not sequence but in parallel, or we call it depth wise, depth first or width first, and there are many concepts. I'll just share with you. Here is the VGG architecture for 19 layer, how they define the layer, image layer, what, like they will have convolution of how much depth. Depth is equal to 64, 3 by 3, and then you have got a, convolution 1.1, 1.2. So basically what it means is you are taking a two-dimension layer, and in that two-dimension layer you are defining how many pixels are there or how many segments are there. You segment it into some numbers, and then when you do a weight addition, there is a standard thing, right? We said in the weight we add weight, right? So a y equal to mx plus c. So you get, just keep the numbers. You are converting everything into numbers. That is embedding. So you take embedding and then you keep on playing with it and try to adjust forward, backward till you are able to get to the classification, which is the final classification layer, 1 and 2. So if you have to detect only 2, then there are 2. If you have 1,000 images are there, then maybe 1,000. So depending on how you get to the number, this is a series of forward, backward, whatever the gradient descent methods and different methods they use. So this is for the sequential. You can do this way. This is not this insertion is the above one, where you keep inserting more and more in sequence. Whereas here you partition into depth wise. That means this is not this way, but this is this way. So you take each layer and different, you depth wise you divide. So how you divide, how you conquer, that is inception, exception, VGG, these are nothing but graphical way of managing the neural network by layers, whether do you vertical layer or horizontal layer, how do you want to define. And so there are some obviously reasons why they do it, because in a to solve, if you have modularity, then it is easy to repeat, and that's what they do. So this is your neural network. Now let's come to LLM. So what is LLM again? We said that it's a large language module. Now why large language? Why not small language? Yeah, it can be small language. But what happens is there are some models, they are called foundation models, which is mother of all. It has everything. So that is the big, that is large. Whereas there may be some base model, which is not as large. It may have a limited input data. It may be trained on limited parameters. So you can have a base model, you can have a large language model, you can have a domain specific model. So models are models, but nothing but bunch of neural network computations. Using PyTorch, you can do any of the models. Why only PyTorch? Because PyTorch I am giving you as a framework, because if you learn one model, others can be easily be folded in. We'll come to that. But essentially what we are trying to do is, in the early days, people used to give word to vector conversion. So what they will do, in the Stanford example, they have given GLOW. GLOW is one of this, what you call, So it's called n-gram. Gram means what? Not the gram, kilogram or milligram, but gram means it's a word. And if you have two words, you call 2 gram, 3 gram, 4 word, 4 gram. So you provide n-gram, the sequence, and then try to predict the next word. So if you have one word, you say hi, then the second would be what? Maybe welcome, right? So the model has to guess that hi, if I say next, maybe welcome. Or if it is maybe how, then maybe how are you, right? So the ability to predict the next word is what word to vector used to do, and you can train it, and accordingly it will go forward, backward, and in a vector array. Vector is nothing but one-dimensional array, right? With a direction. So forward, backward, you can have direction, and that's how you determine word to vector. So earlier days, what people used to do, search. Oh, I'll give you keyword search. You index it so that I can figure out what exactly you are trying to predict, right? What you are trying to find out on a web page, right? So that is keywords you give. Instead of here, you give the keywords and keywords to sequence of keywords. So if you ask a question, where is Argentina? Then say Argentina. What is capital of Argentina? It will give you some answer, and then that is how you figure out whether it's right or wrong, right? So these are some of the encoding mechanism. Now Google started with a bidirectional encoder called BERT. It is a transformer. Everything is a transformer. If y equal to m of x, y equal to mx plus c is a function, and if it is a probability that it is a something, second word which you are trying to detect based on the first word, it's a probability that it may be this. So if the higher the probability, the better. Or you can say lower the, they call it as loss function or error function. Lower the error, the better, because you are going to closest to the results. So this you can do in one direction or bi-direction. So encoding, if you go forward and backward and look at what is going to come, then it may give you better context, and that is where BERT, bidirectional encoding transformer representation of transformation, is what BERT, which Google threw in the opens in the generative pre-training, they call GPT. It's nothing but you train, but you pre-train. So that means you have got sample data of, example, you are trying to find the house price in Mumbai at Nariman Point versus Delhi, whatever the near the Parliament House. Can you even get a house? And if you can get a house, what is the Jantar Mantar or whatever? Or it could be at the whatever the price is, right? So what is the price differential? So predicting the price based on already collected data. So you need data, and that is training. After you train, then you are doing some throwing at it. Hey, this is at Nariman Point. Tell me what is the price. Then it will say, okay, what is the square feet? What is the area? Where is the location? Okay, based on this, based on my previous knowledge, I am going to say this is this many lakhs or this many crores, right? So that's a prediction. So what we are trying to do is we are trying to get some output based on some inputs, and that model which we are saying, it could be a large language model. That means it is fully trained already by GPUs and GPUs and GPUs. It may be it was trained for with 6 billion parameters and all that. And all we are throwing at it is, hey, my question, and it will answer you because it already knows the answer most of the time. But it doesn't mean that it will answer you correctly. It may keep on freaking out after that, saying, oh yeah, it is because it is this and that, and oh, it is very close to the Mantralaya, and that is more close to the what do you call Parliament House, and you didn't ask it. You just say, this is my location, this is this place, tell me the price. So it should shut up and say, this is the price, and just forget about it. Not try to hallucinate or give something extra. So sometimes extra information is not worth it, or it may lead to misleading answer or incorrect answer. So therefore, we don't want all that. So we have to put guardrails to control it. And this generative pre-trained transformers were built initially based on fixed data. There is no dynamic. This is what first time you train. After that, whatever you do is based on that. There is no further input. And that is where we said feed forward, feed backward. And we said that we have to do input from the output to input. And then that is the portion which we. So initially, base models were built, which were based on GPT-2 and 3. GPT-3 and chat, whatever that, chat GPT. So chat is the front end, GPT is the back end. So chat UI is where you throw the questions, and at the back end it goes and sends to the GPT, which is pre-trained, and then it generates the answer, and that gives you back. And you cannot change anything because there is nothing. It is not dynamic. It is fixed training. That is the base model. But if you go to fundamental model, means it is already trained with so much information that it is way beyond. But the size of this is also way beyond. So you cannot put it on your computer and execute it and get the answer. So there is a restriction on whether you should use GPT-2 or 3 or so. There is a model selection. You have to use what model. So details of models are all too many are there. So when we started early in the what do you call 2012 and all, at that time there are like Cafe and Therano were the real initial frameworks. But later on it became that big data and a lot of data started coming in. So Google started putting TensorFlow. Facebook started with a PyTorch. So the originator of PyTorch is Facebook, 2016. And then what happened is a lot of difficulties, different places, but PyTorch was open source and it caught the imagination. It was only a researcher's tool to start with. Now that has become the de facto tool. So you don't have to worry if you learn PyTorch, you can do TensorFlow, you can do, because all conversions is possible these days. So even Microsoft did some CNTK or some toolkit and component neural network or something like that, and Apache had MXNet, Amazon had, all of them have abandoned everything. The only people prefer right now is for deployment, although today what do you call the TensorFlow is preferred, but even that is getting out. So ultimately what will happen, PyTorch is going to win the race. We can bet on it easily. So rather than doing all the thing, we know Python, we know PyTorch, so we focus on that. And for our local, obviously we will focus on RAG model. So these are the models you can see. Everything is chat GPT with GPT-3 was the base model. And then you can see in the diagram, there was something called human reinforced learning. Reinforced learning means if a dog, you bring the food, it will keep running and come to you. So you are giving an incentive to it. If you want it to go out and do the pee and come back and eat, then you will take it out and then you will keep in your hand your food. So you are giving incentive. So reinforced learning, human feedback is the loop. So you have the prompt or the text. So the text you feed to LLM is called prompt. So you do a prompt engineering. You feed the text, it takes the text and then it may be initialized. After initializing, it will come back and you give a human feedback saying that, hey man, this is not correct. What you are telling me, this is not a dog. You are showing a cat and giving me a dog. No, this is wrong. So you are giving feedback. So by feedback, it is going to correct it and it will keep correcting. So the training keeps on going. And at some point of time, it becomes expert. So you're training the model, the neural network, to do approximation as it improves using the RLHF, which is reinforced learning by giving points. So human will determine, good, this is 100%, this is 90%, this is 80%. So you are giving the feedback to the model saying that you are correcting yourself. You correct, this is wrong, that is right, this is wrong. And based on the human feedback, it will correct itself. That is the RLHF. That is reinforced learning based on human feedback. And you can also do a direct parameter of preference optimization, like we did in the case of that gradient descent and all that. That is automatic. So you can do direct as well as you can do indirect. Now the system can be end-to-end. So large language model are a modular, it's a modular system. And you reward the model by ranking the outputs, and thereby this reinforced learning happens. This is what the diagram is showing, and it's depicted at the bottom. Let's go to the some more classifications. What are the models available to, frameworks available to us? So PyTorch is a model, TensorFlow is a model, JAX is a model, NumPy is a model, scikit-learn is a model. All these are models, right? So you can do NumPy, JAX, TensorFlow, PyTorch, whatever model you use. But if you want interoperability, because first is framework, so we have described framework. Second is models. What are the models? We already saw some of the models. You can add more models to it. Like in the last time we saw all the models on the, did I show the models already? No. Yeah, I did show some of the models previously. Yeah, here you have, right? So you can see framework, and where is the models? I think I should have shown some models. I'm missing some models here. Okay. So where is the diagram? Yeah, here. So you can have a lot of models, and the models can be based on, I think I missed some models. Where are the models? Okay. Yeah, I think. So there are models galore, like deep CNN, then models based on the VGG19, LessNet, Inception, Exception. So we did models. So there are models which are usable, and some model out of this GPT, all this GPT is also a model. So there are many models which we already looked at. The point is which model you want to use and which framework you want to use. So you can take a PyTorch and use a GPT, or you can take a PyTorch and use some other model. So you can use a RAG model or RAG framework, and you can use any VGG. You can use Inception, Exception, whatever. So different models can be used along with different framework. Not only that, you can, in this case, why I am saying PyTorch is your source code may be in the Python, and it is a part of a PyTorch model, but you can target it for something different. Like example, it can be anything. It can be a TensorFlow model, or it can be a JAX model. So if you do in PyTorch, you can always convert it to any other model. Same way, conversely, you can take other model and convert it into this model. And this model conversion is using LVY. Okay. So IV, sorry, not LVY, IVY. So IV, two things you can use for portability and interoperability. So you can build a model, you can use a model on PyTorch, and then if you don't want, you want to use a TensorFlow, you can always convert it. That is a model conversion program called IV. Or you can use another way is ONNX. That means you can execute on one platform and then put it on another, convert it and use it. So you can do either ONX, which is a Microsoft model, IV, which is there available for conversion of model from one framework to another framework. So we know the framework, we know the models, we know the portability and interoperability. All this can be done. And important thing is to make sure that if we, because most of the models available are example proprietary. Example, you have GPT-4 is proprietary bit, GPT-3 is open, but it cannot be dynamic. If you don't have dynamic, you can't get it. Cloud is another model. This is from Anthropic, I think. Gemini is the one which is the model from, oh, so different models when I am talking about, it's not just those old models, but the newer models also. Like Gemini is the model of Google. Then you got Llama, which is the model of Facebook or Meta. And there are many open, so there are some models which are available from latest and greatest is that deep, what is it, deep, I forget. Yeah, DeepSeek. So there are many models which are there, and Coin is another model which is open. Mistral is for mixture of experience you put together. Each model has a theory behind it. You can take any number of models and you can slap it into one of the PyTorch and then keep and execute it. So models which are free and easily available in open source, you can pull and put it into framework and execute it. So framework is a way to use the model. Now there is one more framework, RAG framework, which I wanted to leave thoughts before we close. So RAG, I said already I gave you RAG. Why? Because that you can do it on your own machine, and even if it is a XADC, you can do it. You don't have to use CUDA, which is the so there is a unified computer unified device architecture called CUDA, which expects that you have to do parallel processing. So you create kernels. They call it kernels. Kernels are nothing but streams. So devices in the devices. So if you have a processor and you have a device which is a GPU, processor generally unifies. So it says take this, split it into n single instruction multiple data. They call it SIMD. So single instruction is add this vector or multiply this vector. But then this vector is 512 byte. So if it is 512 bit, if it is 512 bit, my processor is only 64 bit. How am I going to process the 512? So you divide it into 8 pieces. So you do like arithmetic logic, you do borrow, carry, borrow, like we do multiplication and addition. We multiply first one digit by another digit, then take the result and then put forward into the next multiplication, add that. So that is carry forward, borrow. Carry or borrow we use. Same way overflow at the end it happens. So all these carry borrow concepts, segmenting the 512 bit into 64 into 8 and then doing parallelly the 8 process, but at the same time making sure that they are doing single instruction on multiple data, 8 parallel I can do with 64 into 8. So that is the vector processing. So what it means is you can take a risk-based implementation on the instruction set architecture, which is easy, no licensing. You can easily, no licensing, it is royalty free, and you can design your own vector processor. So our goal is at the end of it, we are trying to do AXPU, which is nothing. We can use RAG and we can give some input to it. Not only that, at the hardware side, it is complex. There will be drivers which will drive it. So there is an upper driver, which is abstraction, lower driver, which is depending on the hardware. So if it is an Intel x86, it will do some transpilation and all that, which will be different. Whereas if it is a what you call a intermediate representation, they call it as IR. So some IR it is, which could be like it could be Java based. If it is Java based, it will be JVM based. If it is some other, it will be some other base. Just hold on one sec. Hold on one sec. Yeah, I'll call you back. Yeah, give me 5 minutes. Thanks. So what happens is we can use the intermediate representation and we can do transpilation. So those are the options we have got. So when you have models, you can look into the details. There is something called Hugging Face, which provides board called as Chatbot Arena, and you can go and look at it. It ranks the models. There are thousands and thousands of models. As you can see, this graph, it shows that PyTorch has around 6,000 models available, and this is a 1-year-old chart. Now I don't know how much it will be, 8,000, 10,000 maybe, but gives you idea, right? PyTorch has got the most model. TensorFlow has little because difficult to execute, but they are more deployment centric, and then you can have any other platform. So what it means is that you can have models and they can be in a particular Hugging Face. In this case is a place where, so if you want to use a model and if it is licensed, so the license guy, if it is licensed by Gemini example or maybe Gemma, which is a lower version of 2 megabit or 1.5 megabit, whatever they give, because that much, the more the bigger the model, you need bigger the memory and bigger the disk space, and you don't have that, bigger the compute processing. So you always try to choose a smaller model, go to Hugging Face portal, huggingface.ai, I think, and then go there, and then they will ask that unless you sign the agreement with that Google or whatever, that Kritrim, or they will not give you the model. And then so you sign that agreement, and then you go there and get it, and then you can use it on the Hugging Face. But which one to choose, that's a dilemma. So you go to the chatbot arena and select from there. There is a elo rating. Elo rating is like a chess. If you play chess, you are ranked as top gun. You are the top 10%, top 5%, top. So whatever that ranking they give, similarly they give ranking. But in spite of all that, most of them are proprietary. So we choose the one which is usable, and that is where you don't even have to go to Hugging Face. That's what I want to do. If you use RAG, there is a tutorial available called Ulama and RAG. So what is Ulama? Ulama is a for using on-prem model, which you can do. And I think I have Sujay, who will present sometime on the Ulama and how to use on-prem model. At some point of time, we'll do it. But at this time, I do want to say that before I close, I just want some Q&A, and with that, after that, I'll stop recording. So we are going into Q&A mode. Anybody can open out and start questions. So I'll stop sharing, and I am back to the individual. Yeah, go ahead. Any questions? Start at least a couple of questions. Jamie, you are going to take next. So what is your question?
Uh, not from me for the time.
Okay.
I'm still going through some of the things that you discussed
Mhm.
while presenting. So, uh,
Okay.
yeah,
Yeah. But one thing is, I just want to say that step by step, Jamit is going to go through one model at a time. Okay. Go ahead. Sushant?
Okay. Thank you, Prakash. I want to ask, like, if I want to go ahead and start implementing this model, what should be the step one um, for this? Like, where should I start?
So
Uh,
you have a notebook with you?
yeah.
So I have shown the tutorial for Olama at the end. Okay. So
Okay.
your homework is to start with Olama. Install Olama, and there is a video associated with that. Uh, I think I will just put it on the chat window. You go with this, and of course, this is a three and a half hour presentation, which I don't think it's worth doing that. But more importantly, what I want to say is uh, just follow the tutorial for Ulama. And that slides I will present, but before that, let me just go. Can somebody put that? Jamie, can you put in the chat window the uh,
yeah.
yeah,
Just in
yeah,
some time. I'm from Mumbai, so that's why.
yeah, okay, okay. So because I am not able to get, yeah, I think I'm getting there. Let me see if I can get there. I'll put it. What happened to my slides?
Yeah,
I,
sir, is it the same link which you shared me last week? I mean, couple of days back on the
yes,
Olama tutorial? Yeah, I will share. I will put that link. Yeah.
put that link, Olama. So Olama is the first step. Okay. If you are able to install Olama on your notebook, then you choose the model from, let's say, uh, a model. You pick up a model, and the simplest of the model you can pick up. You can take a
Got it.
Llama or maybe O1. Even this is that Alibaba's O1 is the easiest one, I believe. It is MIT licensed. So if you take MIT license, you can use it. So I will say try anything. I am not particular about the model. All I want you is to learn how to use the model. right?
Got it.
Take some model, try using some simple thing so that you can actually use it out. And you can see in the chat window, there is a Olama course, Build AI, Apply Locally, YouTube. And that YouTube link is there or not? No, link is not put there. Oh yeah.
Yeah, sir, it is somehow taking the text only. Now I took the link. Yeah.
So go. So this was Sushant, right? Sushant from this is from Delhi, right? RCDU, or you are from somewhere else?
I'm from Bhopal, Madhya Pradesh.
Oh, Bhopal, Madhya Pradesh. So you are at Jain, Ujjain area, or Bhopal? Bhopal, okay.
Yes.
So when did you hear about this? You saw it in which part you were in the? You were in the study group, DISC-5 study group.
Yeah, I'm an AIML study circle.
AIML study. Okay.
I just restarted from today.
Yeah, good. That's good. So very good. So Sushant, you are welcome. You can go to this YouTube video, and it's a long, arduous thing. All I would say is first go with the we have some first text install the Olama. Once you install the Olama, then you go directly to maybe RAG directly. I would prefer if you can go to RAG model,
Okay.
which is at the end. Instead of reading through that all 3 hours of video, first 10, 15, 20 minutes or half an hour until you install Olama, then you go to the end. From end, you click 1 hour less and go from there so that you are focused mainly on the RAG model.
Got it.
So, because Python, PyTorch, Olama, we want RAG because RAG means you can do it on your own, in your own data, in your own desktop, and without even GPU. If you have GPU, you are lucky. You don't have GPU, still you can do it.
Yeah, I don't have GPU, so
That's right. That's the reason I said go with the RAG model so that you can build your own database and you don't need more than 20 gigabyte of disk space. And it can be done on a Windows, it can be done on a MacBook, or it can be done on a what you call Ubuntu. Okay, so any is okay. So does that answer your question?
yeah, that I'll start doing this.
Yeah, you start doing that and ask question in that whatever group you're in. Okay.
Yeah, sir, I have one question. How this PyTorch we can fit into the stack? Say, for example, whether it could be on premises or the cloud offering. So it will directly go into Kubernetes or deployment. We'll deploy it in Kubernetes, or it will the pipeline will use that PyTorch. So we have two options.
No, yes. Whatever your compute is, whether you are in virtual or in Docker or wherever, you do have a compute, correct? And within that you install this PyTorch, or within that you install this Olama. So that means you have master and you have got workload, right? So you install PyTorch into workload cluster.
Okay.
And in
Yeah, I got it.
So you keep everything in workload cluster because you are talking of a workload which is based on some model. So what you do is you take a workload cluster, not the system cluster. Don't spoil the system cluster or the default cluster. Or if you are only using default cluster, then you do it on a container, right? Whatever that container is. Create a cluster with specific requirement for that workload and run the Olama and PyTorch on that. But I would prefer that they be on the same cluster. That is, the Olama and the PyTorch and Py all are in the same container initially. Later on, you can shift the divided, like you can keep the Olama in one cluster, then the workload in another, because model requires deployment, right? You are taking a model is nothing but it is a PyTorch. This is a framework. PyTorch is a framework. All it will contain is it will contain the library. But to do the computation and all, you'll have to write some sample code, right? And that sample code will call the PyTorch library called torch something, and you can do some computation on that, right? Like gradient descent. And then you are arriving at result. And that result Once it is done, then you want to scale. So before scaling, you don't have to worry. You put it in one cluster, whatever that cluster is, and even in default you can do it. There is no restriction. But then you should be able to scale it, so you'll have to separate out. So system you keep in one, and the workload you keep in different. So initially you can do it in one container, and then afterwards you can split it into multiple containers. So initial default, you don't even bother. Just take a cluster container, dump everything into that, install Ulama, install the whatever the PyTorch, and then use the Ulama, and then start using it. Ulama is nothing but a local use, right? And within that, whatever model you use, it allows you. You can use Py to code it, Python library, and you can use PyTorch for other whatever the model deployment, design or modification, and then deployment. Okay. Anybody else? Any questions? Shall we wind it up? 5:30. I know it.
Yeah, sir. One more thing. When it comes to our the current project, what we and you and Amrish is handling. So
Yeah.
in that part, the vectorization part. In that part, we will be again using this PyTorch framework for vectorizing. Correct?
So what I'm right now, my belief is that if any model we use, any model, irrespective, we should use PyTorch. Because
Okay. All right.
so it doesn't matter what you are doing, whether you are doing vector processing or RISC-V processing or whatever atom processing. Architectures don't mean anything to us because we are doing at abstraction level, which is at a higher level right now. When we transfer and execute on a host, the target machine may differ, right? You can right now do it in x86 also, so what? So architecture independent at this time, you are doing it the architecture. Once you translate into target machine where you want to execute, then the problem will start. That time we'll have to see whether we have to do a IV or we have to do ONNX or what kinds of portability, interoperability, all that we'll worry about, right? At the learning time, you don't have to worry about first time doing for anybody, right? We are not hosting it anyway. Once we come to hosting, we'll have to then worry about it. Okay? Does it explain?
Yeah, I got it, sir. Yeah.
Okay. I
Thank
think
you.
I'm going to end the call right now because I have to go out. But what we do is we'll repeat this. Jamit will try to explain with one notebook, one application, one notebook, how to execute using the notebook, Jupyter notebook. So that means you will get the code, you will see what it does and what application he is using, how he is using. This is PyTorch based. So the idea is to learn PyTorch as we do application after application. We will have some 7 or 8 applications over 7 or 8 weeks. In case in between, if somebody is ready to present something like Sujay wants to do something, we will definitely let him handle it. Or if Amrish comes with something, or Mayank also comes up with something, Jaimit, you can work with him, whichever way. Okay. So with that, we will end the call. I'll stop recording